this is experiment 2, and experiment 2 says try to establish the system model below in Simulink and use the unit step signal and 3 sine 4t signal as input respectively to the system to obtain the output signal. So we are supposed to draw this automatic control system into Simulink. And what is Simulink? It's the same as MATLAB, but here we are in MATLAB, and you just need to find this Simulink library. So when you click on the Simulink library, it takes time to open. So I already opened before I started the video because we need to save time. So here, Simulink. When you open Simulink, this is what you probably find out or see. So here, just go to File, go to New, go to Model. Okay, so now we are in our model. In the model, here is the libraries. So you click on the libraries. So after clicking on the libraries, this is what you see. So here, commonly used blocks. We have continuous. We have other libraries. Okay, so that's what we are going to use to draw our design. So first, you see we need two transfer functions. This transfer function, this transfer function. So we are going to take this transfer function and this transfer function. So first of all, let's back to Simulink, and the transfer functions are found in continuous. They are all continuous transfer functions. So when we double click on continuous, you will see this here, transfer function. So we will take this. So first we drag this. So we drag this here onto our working space. So here you can maximize it to make it easy to see. Okay, so yeah. So now we need two transfer functions. So in order to get the next one, you can right click and drag to copy, to copy another. Then after right clicking and dragging, we can double click, then we can change the stuff. So here is 1 over s plus 1, and this 1 over s plus 1 is the same one we have here, 1 over s plus 1, but here is different. Here our numerator is 6. So we go to, after double clicking here, this comes numerator is 6. So we type 6, and then our denominator, let's check. Our denominator is 1, coefficient of 1, 2, and 1. So 1, 2, 1. So here in Simulink, double click here, 6, 1, 2, 1. All right, so we click OK. So as you can see, our transfer function has been written very well here. Okay, so just to make a difference. All right, so now we connect them. To connect them, you just need to click on the arrow here. Click on the arrow here. Sorry. Oh. All right, so here we are. We join them. Just click to join, and that's it. And then now, if you look at this design, we also need a summing point. Now, the summing point in here, we can also open our libraries. The summing points are mathematical operations. So you find mathematical operations here. So you move down, and as you can see here, we have sum. So you can drag sum here. So this is summing point. But remember, or take note, this is plus minus. But the one we have just taken is plus plus. So in order to change this, we can just double click. After double clicking, these are the signs. So we just remove one plus and add a minus. And okay, so as you can see now, we have plus and minus. So now we can join them. Can click and drag, hold the left mouse button, and then you can leave it here. You can extend this as well in order to make your diagram look much nicer. So then we connect from here to here. All right, so now let's back. Now, as you can see, we need two scopes. The first scope for the output, and the second scope for the input. And then we also need a sine wave, but we shall go for the sine wave first. So now we go for sine wave. So first we go back to our libraries. Okay, so this is our library, and the scope can be found in, no, sorry, um the sine wave can be found in sources. So here we click and we drag, and then we drop it here. So now we connect this to this. Okay, so now we have connections done. And next we need the scope. Now for the scope, we are going to go back to our libraries and we go to sync. The scopes can be found in sync. We take this scope, so syncs, we go to this scope, we click only one, and then we keep it here. But we can right click and drag to take another and take it here. Right click to duplicate. When you right click, you duplicate, and then we can connect this scope to this joint, and then this other scope to this node. Okay, so our design is finished, but it says use the unit step signal. And so first we are using unit step, right? Yeah, so unit step signal, and also we are going to use 3 sine 40 signal. So now we are putting in the 3 sine 40 for, so we are going to consider this is the 3 sine 40. That's what we are doing first, because there are two different inputs. Remember, the first input is signal, unit step signal, and the second is 3 sine 40. But okay, this diagram gave us the sine here, right? So let's start with sine. So we are starting with this. After we will go for unit step signal. So here we can go back to lab, then we open we double click on the sine wave, double click, and remember in the function gave us, they said 3 sine, which means amplitude is 3. So if amplitude is 3, we need to put 3. Remember, this is amplitude 3, this is frequency 4. So we need to do some changes to our sine wave. So when you double click on the sine wave, amplitude is 3 and frequency is 4. There's no bias and there's no phase. So just this, and there's no sampling time. So okay. All right. So now we are done with this. Then we will change this time to 50. Okay, so that we can get more points. These are the points for plot. Then we can run. So when we run, we will wait for the bar to load. Loading. So yeah, we need to allow. So it's compiling. So after compiling, it's done running. So now we can double click on the scope. Double click. So when you double click on the scope, you should actually see your value, but let's check what's the problem. Okay, let's click on this scope. Let's input Y. Let's check the diagram. Yes, everything is fine. Right. So okay. All right. So now, as you can see, this is our signal. So this is the signal we need. This is the output signal. Okay. But if you double click on the scope, this is input signal. Okay, of amplitude of 3. So as you can see here, and the frequency is 4. All right. So we are going to save. Actually, with this, you can just take a screenshot, or you can print. Here you can just take a screenshot. In order to take a screenshot, we can go here to our window, type snipping tools. When you get the snipping tool, you open the snipping tool. So here you would click new, so it will happen like this, and then you can snip the graph this way, so it will show. So this is now our graph, this picture we have just snipped, and then file, save as, and then you just save. So after take this file to your Word file. All right, so that's it for this. And then so this is the input. So you save the input, and also you need to double click here, get the output. This is the output, and you save the output. So as you can see in my Word file, in my Word file, the input signal. This is the input. So this is it for the sine wave. Now to go to unit step signal. To give a unit step signal, we need to change this input. So first we can go to our libraries, unit step. So we can still go to sources, and then in sources we shall look for step. So this step, so you drag it here, and then we can delete this. Okay, just click on it, and then you can even cut. So when you cut, this should go. So when it's gone, you can drag this into here, and now you have a step signal. When you double click, you realize it's only one. No need to change anything here. So this is our step signal. Then we run to compile and debug. So after this is done, we shall open this file, the input. This is now the input. So as you can see, this is how the input looks. Okay, this is how the input looks. And then the output. This is how the output looks. So we shall save both files into MATLAB. So and put them into our, just like the taking pictures stuff, output. Bringing the input. So you should bring both unit input and unit output in file. So that is it for this question. We've started this question, question 1. So we'll do in the next video.